In this video, we look more closely at identifying and naming the most important polyatomic ions and oxyanions. Hundreds of polyatomic ions exist, and some of the most important examples are shown in this table. The bolded examples are ions you should become familiar with, as they are very common in chemistry studies. Unfortunately, there is no easy way to learn the names and formulas for polyatomic ions, as they do not easily relate to the periodic table in the way that monatomic ions do. The inability to recognize polyatomic ions in names and in chemical formulas is often a stumbling block for many students starting out in chemistry. So here are a few hints to help you out. Only 3 of the polyatomic ions in this table are cations: the ammonium ion, NH4+, the hydronium ion, H3O+, and they are both very important for the acid-base chemistry concepts that follow in this series. And the third is the mercury 1 ion, which is a polyatomic Hg2 2+ ion containing 2 mercury atoms bound together. The 2+ charge is spread across both atoms, effectively giving each one a 1+ charge. The 1 in brackets actually refers to the oxidation number of each mercury atom, and we will deal with oxidation numbers a little later in this video series. For now, however, the 2 most important polyatomic cations to recall are the ammonium ion and the hydronium ion. Only 4 of the polyatomic ions listed in this table have the "ide" ending: the hydroxide ion, OH-, the cyanide ion, Cn-, the peroxide ion, O2 2-, and the azide ion, N3-. The naming of these ions come from historical precedents. The hydroxide ion is the most important of these to remember. Most of the ions listed are oxyanions, which contain oxygen combined with another characteristic element. When a characteristic element forms more than one oxyanion, which applies to most cases, the name of the oxyanion begins with the stem name of the characteristic element and ends in either "ate" or "ite" to indicate the ion with the greater or lesser number of oxygen atoms. For example, consider nitrate, NO3- and nitrite, NO2-. The name of both oxyanions start with the stem name for nitrogen, being nitra, and end with the "ate" for the ion with the greater number of oxygen atoms and "ite" for the ion with the lesser number of oxygen atoms. Other examples include sulfate, SO4 2-, and sulfite, SO3 2-, phosphate, PO4 3-, and phosphite, PO3 3-. And finally, chlorate, ClO3-, and chlorite, ClO2-. In the case of these chlorine-based oxyanions, there are actually 4 different oxyanions. When a characteristic element such as chlorine has more than 2 oxyanions, the suffixes "ate" and "ite" are not enough. In such cases, prefixes are also used: hypo to indicate less oxygen, and per to indicate more oxygen. So for example, we see the hypochlorite ion, which has 1 less oxygen atom than the chlorite ion, and we see the perchlorate ion, which has 1 more oxygen than the chlorate ion. Some oxyanions that have a 2- or 3- charge can readily add 1 or 2 H+ ions to their structure. These ions are named by adding the prefix hydrogen or dihydrogen to the name of the oxyanion. One example includes the hydrogen carbonate ion, HCO3-, also known by its historical name as the bicarbonate ion, which forms from the carbonate CO3 2- ion. And you should note that not only does the chemical formula change with the addition of the H+ ion, but also the overall charge increases by +1. Another common example is phosphate, which becomes the hydrogen phosphate ion when 1 H+ ion is added, or the dihydrogen phosphate ion when 2 H+ ions are added. Again, note the change in charge each time a H+ ion is added. Finally, sulfur can sometimes replace oxygen in an oxyanion. In such cases, the prefix thio is used. One common example involves the sulfate ion, SO4 2-, which becomes the thiosulfate ion, S2O3 2-, when one of the oxygen atoms is replaced by a sulfur atom. Another example involves the cyanate ion, OCN-, which becomes the thiocyanate ion, SCN- when the oxygen atom is replaced by a sulfur atom. Now, at first, some of these rules can seem complex, but with practice they will become more familiar to you. For now, focus on the ions that are bolded in this table, and in particular these ions: the carbonate ion, the hydroxide ion, the hydronium ion, the ammonium ion, the phosphate ion, and the sulfate ion.